Welcome to the session on integration, the Trapezium Rule. The objectives for this session are to use the Trapezium Rule to approximate the area under a curve. Some functions can be difficult to integrate algebraically. For such functions, we can use numerical methods to approximate the area beneath a curve. So let's take a look at this example, y equals f of x. We're going to find the area beneath the curve between the limits a and b, as shown. This is represented by this expression, integral from a to b y dx. In other words, this shaded region. We're going to begin by dividing up the area into n equal strips. Each strip has width h, where h is equal to b minus a divided by n. Let's calculate the value of y for each value of x that forms a boundary of one of the strips. So in other words, we find y for x equals a plus h, x equals a plus 2h, x equals a plus 3h, all the way up to x equals b. For n strips, there will be n plus 1 values of x and n plus 1 values of y. You can label these values y0, y1, y2, all the way up to yn, as shown here. To approximate the original area, join the adjacent points to form n trapezia, as shown. The integral of y between the limits a and b dx is approximately equal to the sum of the areas of the n trapeziums. Recall that the area of a trapezium is equal to a half times, and in this diagram we have y0 plus y1 times h, as shown. So the integral of y between the limits a and b dx is approximately equal to the sum of all these trapeziums. In other words, the first trapezium plus the second plus all the way up to the last trapezium, as shown here. Factorizing gives us this expression, or this one. And so we have the trapezium rule, as shown here. Now let's use this trapezium rule on some examples. Pause the video and have a go at this example. Press play when you're ready to view the solutions. So let's solve part A first. The diagram shows a part of the curve with the equation y equals 4x minus 5 divided by x minus 3 times 2x plus 1. Given that I equals the integral between the limits 0 to 5 over 4 of this expression, complete the table on your screen. So let's solve this. When x equals 0.25, y equals this expression. And plugging in x equals 0.25, as shown, gives us the value 0.9697. And so we can enter this value into our table. Now let's see what y equals when x equals 1.25. Plugging this into the expression for y gives us that y equals 0. And so we can put that into the table as well. Now let's take a look at part B. Given that the integral I is defined as shown, use the trapezium rule with the values of y at x equals 0, 0.25, 0.5, 0.751 and 1.25 to find an approximate value of I. So let's solve this. Now h is equal to b minus a over n, which is equal to 1.25 minus 0 divided by 5. This is equal to 0.25. Now let's apply the trapezium rule, as shown here. And calculating this gives us that the integral is approximately equal to 0.7313. Now let's take a look at part C. We are required to find the exact value of I, giving our answer in the form ln of a over b. So let's solve this. We're going to use partial fractions to express our integral as shown. The first term is equal to ln of 2x plus 1 between the limits 5 over 4 and 0. And the second term is ln of x minus 3 between the limits 5 over 4 and 0. And this gives us ln of 7 over 2 minus ln of 1 plus ln of minus 7 over 4 minus ln of minus 3. And this equals ln of 7 over 2 plus ln of minus 7 over 4 times minus 3. And this equals ln of 7 over 2 plus ln of 7 over 12, which equals ln of 49 over 24. Now let's calculate the percentage error of the approximation in part B. We have the exact value of the integral, which is ln of 49 over 24, which is equal to 0.7138 to 4 decimal places. And from part B, we have our approximation, which is 0.7313. The percentage error is equal to the estimated minus the exact divided by the exact times 100. So 0.7313, which is the estimated value, minus the exact value divided by the exact value times 100. And this equals 2.5%. And therefore the percentage error of the approximation in part B is 2.5%. This brings us to the end of this session. If you have understood its contents, you should be able to use the trapezium rule to approximate the area under a curve. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.